Stan Gibilisco here. This is the 15th of April 2014. Last night here in the Black Hills of South Dakota, we were blessed with clear weather, so I got to view the total lunar eclipse. And I noticed the same effect that I always see just before and after a lunar eclipse, provided that the moon is high enough in the sky so that you can really notice this effect. It is the fact that the full moon is brighter than ever just before it begins to enter the Earth's shadow. And just after it finishes leaving the Earth's shadow, again for a couple of hours, it's brighter than ever. And it's hard to miss that. If you really look at the moon, you think, wow, that moon sure is bright. And then after the eclipse again, wow, you know, that moon is just unusually brilliant. Well, it's not just your imagination. There is an effect called Gegenschein, which is a German expression which means counterglow or countershine. When something is exactly opposite the sun and it reflects light, and particularly if it has an irregular surface, as the moon does and as just about every cosmic particle does, Gegenschein will become apparent and make that thing look brighter than ever. And I can describe for you a very simple experiment that you can do the next time you happen to be standing in a field or a yard with short grass. This is you. Forgive my artistic inexpertise. This is your head, of course, this upper part right there. That's your green head. Now imagine that the sun is somewhere back up behind you like this and shining down at an angle. There is a particular line where a ray from the sun will go right through your head and strike the ground with that short grass on it. If you will look at the shadow of your head on the ground, there's the shadow of your head, and of course, here's the rest of your shadow. If you will look very carefully, right around that shadow of your head, you will seem to see an unusually bright region, almost like a halo. You will see kind of a halo. Well, that doesn't necessarily mean that you were an angel or that your shadow is an angel. What it means is that every blade of grass in this yard has its own shadow, and when you look right along that line at the shadow of your head, every blade of grass eclipses its own shadow, so you don't see any shadows of blades of grass right in this region. You will see shadows of the blades of grass in every other region, and so they will look dimmer. And the effect is not just very mild. It's actually quite pronounced, and you might even see it on a concrete surface or any kind of irregular surface. In fact, I've even noticed it when flying in an aircraft. In fact, it's actually, you can locate where the aircraft's shadow would actually be many times, especially if you're flying over, say, farm fields in the Midwest and things like that. And here's the aircraft. And then again, here's the ray of sun, and here's you, right there where that ray intersects the aircraft. And here is the shadow of the aircraft. Now, if that aircraft is flying at, you know, something like 37,000 feet, the shadow isn't going to even appear at all because the sun is a finite-sized disk, and the shadow only goes so far before it dissipates, and it dissipates long before it gets to the ground. But you can still see that counterglow, that Gegenschein. And in that way, you can tell where the shadow of the aircraft is, and you can actually watch that Gegenschein move along the surface and intersect various features of land, farm fields and roads and lakes. Well, once you get over a lake, though, that Gegenschein is going to disappear, because in most cases, unless it's a rough, frothy lake stirred up by the wind or something. But you can almost always see that on a sunny day. I've even seen it in the clouds. I've even seen it occur in the clouds, because every droplet of water eclipses its own shadow that lands on other droplets nearby. And that effect produces a pronounced glow. Well, now let's look at what happens during a lunar eclipse. And I saw a really kind of a neat little diagram of the Earth's shadow and the way that the moon passed through it last night. The outer part of the Earth's shadow is relatively faint, or relatively, I guess we could say, partial. When the Earth completely eclipses the sun, that is a darker part of the shadow. This darker part in there is called the umbra. And this outer part is called the penumbra. As the moon, and it's a disk maybe about that big, passed through this shadow from right to left. Well, actually, it didn't pass. It passed through part of the umbra like this. So the moon was totally eclipsed only during part of the eclipse. If you were on the moon and you watched this eclipse, you would see the Earth partially obscure the sun in the penumbra of the shadow, and then when the total eclipse of the sun as seen from the moon occurred, you would be inside of the umbra of the shadow, and then you would emerge into the penumbra again. Just before the moon begins to enter that penumbra, and just after the moon leaves that penumbra, the moon is almost at perfect opposition with respect to the sun. That is to say, the Earth is almost exactly on a line between the sun and the moon. When the Earth is precisely on the line between the sun and the moon, you see the totality of the eclipse. So the moon is dark. But just before the penumbra begins to darken it, and just after the penumbra stops darkening it, you will see the moon at its brightest that you will ever see it. And the reason is that the shadow of every irregularity on the surface of the moon is eclipsed by that irregularity itself right at that point. So there is, in fact, a Gegenschein region like that, sort of, that exists in space in the region roughly opposite the moon. And when the moon passes through that Gegenschein region, it brightens dramatically. And that is why you see that effect. It's the same effect that you see around your head when you stand in a grassy yard on a sunny day. And it's the same effect that you see when you're flying in an aircraft over farmland in the Midwest during the summer on a sunny day, and you see that counterglow. It's the exact same thing. In fact, it occurs with cosmic particles in between the planets, dust grains, and every other particle. The problem is that these days you don't see that counterglow in space. unless you happen to be privileged to live in a very rural area. I am privileged to live in such an area, but I still live in a small town and I have to get outside of town in order to be able to see that effect. And skies aren't that often clear here in the Black Hills. There's a lot of clouds and a lot of precipitation that falls, and that's another effect that maybe I will describe someday to you. But go to Wikipedia and look up that Gegenschein, Gegenschschein, Gegenschein. That will describe for you the effect in interplanetary space along the plane of the ecliptic, but the same effect, the Gegenschein effect, I guess we might call it, is responsible for that brightening of the moon. And next September, we're going to have another eclipse. Is it September or October? Another lunar eclipse. This Gegenschein effect will take place whether the eclipse is partial or total. Just a couple of hours before and a couple of hours after totality, you will see this Gegenschein effect, just before the moon begins to enter the outer part of the Earth's shadow. So look for it next time. Tell them I sent you. Stan Gibilisco, proprietor and operator of the website sciencewriter.net. Until next time, so long.